Hi folks, we're going to take a look at page 110, number 5. So the question gives us two lines, and in A they want us to find their point of intersection, and in B we want to find a vector equation for a line perpendicular to both lines that passes through their point of intersection. So this first question here is very straightforward. For this second question here, well, let's draw ourselves a little picture. Okay, so there are the two lines. So here are two lines, okay? They're telling us to find a point of intersection, so we'll assume there is one. We should show that there. And we want to find the equation of a line that is perpendicular to both of those lines, okay? Now, of course, these both have direction vectors, and this line here will need a direction vector. So I think you can probably see that if we take the cross product of these two direction vectors, we will get a vector that is perpendicular to both of the lines. Hence, it'll work as a direction vector for the line we're looking for. Okay, but let's start with part A, which is to find the point of intersection. So we'll try to do that as quickly as possible. So here we're going to equate the x, y, and z components, since they have to be the same for point that's on each line. So equation 1 will be 1 plus 3t. The x component from the first equation, and that has to be equal to negative 2 plus u. Okay, x component of the second equation. So here we'll do negative 1 plus 2t, and that's got to be equal to negative 3 plus 2u. And then our third equation, the z components are going to be 1 plus t is equal to 0 plus 3u. Okay. So here I can't say that there's an obvious set of equations to take, so I don't know, we'll take 1 and 3, okay, and we'll get rid of those, we'll get rid of the u's. Okay, so we'll multiply equation 1 by 3, okay, and what do we get? We get 3 plus 9t is equal to negative 6 plus 3u, okay, and then we'll take equation 3, and then we can leave that as 1 plus t is equal to, and just 3u on that side, and then we can subtract. So notice here I didn't simplify the equations first. I could have done that, but especially with this 3u, I figured I'd get right to it. Okay, so 3 minus 1 is 2. 9t minus t, so plus 8t is equal to, those disappear, so I'm left with negative 6. Okay, and here if I take the 2 to the other side, I'm left with negative 8 divided by 8 is negative 1. Okay, so I know that t is going to be equal to negative 1 to solve 1 and 3. Let's find u. So I'll take equation 3 here, and 1 plus negative 1 is equal to 3u, and since that's 0, u has to be equal to 0. Okay, so now remember we just found the u and t values that solve equation 1 and 3. I need to make sure it also solves equation 2. So I'm going to take equation 2 here, and I'm going to start with the left side. I have negative 1 plus 2t, so here we have negative 1 minus 2 gives me negative 3, and then I'm going to take the right hand side, which is negative 3 plus 2u, which is equal to 0, which also gives me negative 3. So that means there is a point of intersection, and in order to find that point of intersection, I just have to plug either t into the first equation or u into the second equation. And since u is equal to 0, I think that's the easier one. So here we have negative 2 plus 0 is just negative 2, and then negative 3 plus 2 times 0 is negative 3, and then of course 3 times 0 is 0. Now notice here, not surprisingly, the point of intersection was actually the given point in R2, because that's what you would get if you may choose u to be equal to 0. Okay, so we have our point of intersection. So now in part B, recall that we want to find a line that's perpendicular to both, okay, and passes through that point of intersection. So we have our point, and here we'll look for the vector equation. So we'll call our given point R0 is negative 2, negative 3, 0. And in order to find our direction vector, we're going to take the cross product of these two direction vectors. So we'll take the cross product of 3, 2, 1, and 1, 2, 3. Okay, 3 and 1, and that'll give us our direction vector. So let's calculate that. We've got 6 minus 2 is 4. Okay, and then here we've got 1 minus 9 is negative 8. And here we have 6 minus 2 is again 4. Okay, so this direction vector, okay, will be perpendicular to both lines, hence parallel to the line I'm looking for. Now, since I want to simplify my life, I might as well simplify this vector here. So instead of using direction vector 4, negative 8, 4, I'm going to divide all that by 4 and use the vector 1, negative 2, 1. Okay, that really is the preferable version of the equation, and now we can write our equation. It is our given point, negative 2, negative 3, 0. Actually, the vector to that given point, plus, and I won't use t and u since they were already used, so I'll say s times my direction vector 1, negative 2, 1. And there we have it.